Like I said earlier on, calibration is not set up. So we'll look at calibration and how you calibrate for your 0 degree and your shear wave. The concept is just simple and straightforward. If you are calibrating, you are trying to ensure that your readings you are getting are accurate. So before you talk about calibrating the unit, you should have done your setup. You should have set up your velocity, your frequency, and the rest, so that you are getting the right readings and every other thing is working before you now do your calibration. Normally, when you check some books, some literature, you will see the word range calibration. That's why we brought these two terms out. When you are doing your calibration, these are the only two things you are supposed to adjust. Before I talk about the calibration proper, let's look at this whole concept of range. If you look at a typical UT machine, a typical flaw detection, or take note, in some procedure you will be told that you should use a UT machine with an A scan. Normally, when you have thickness gauge, like you have your dimeter, your signals, and all that, they are not flaw detectors, and you cannot use them in this sense when you talk about calibration. So they don't apply. So you are doing this calibration using a UT machine that has an A scan. And if the UT machine has an A scan, it will have a screen division, which we call the graticals. The graticals. So you have something like this. Okay, my marker is not working. Let's get some more. So normally you are going to have 10 divisions of your screen. So I'm going to have 1, 2, 3, 4, 5, 6, all the way to 10. For you to understand your calibration results, you need to know how to play around with this, your screen. 10 divisions. So you are going to know how to play around number of divisions, versus the thickness. What does this mean? Number of division is constant, is usually going to be 10. Your thickness is what vary. So what does that mean? My screen does not change. There will always be 10 division. If I come to this block, let's say I'm doing 0 degree, which is thickness, which is, let's say I take this as my known thickness. For this block, this thickness is 25 mm. This is 25 mm. If we compare it to our range and number of divisions, so thickness for this block that we are using for this demonstration, 25 mm. The numbers of echoes that are going to come out in your machine, it will be based on your range. So let's break it down. If I set my range for 50, what it means that my screen that has 10 division is going to split 50 into 10 places, which means for this unit that is working in the range of 50, it will be 50 divided by 10 division. So which means here will be 5, 10, 15, all the way to 50. For a block that is 25 mm, which means 5, 10, 15, 20, 25. So which means my first echo is going to come out at 25, and the next echo is going to come out at 50. Which means for a range of 50, we are going to have 2 echoes. For your machine to be calibrated accurately, it means your first echo should be at 1, 2, 3, 4, 5 in the 5th graticle. This is very, very important. For an experienced UT technician, you don't even need to even look at the values that your machine is giving to you to know that the calibration is correct. Merely looking at the placement of your echo, you can automatically know that your machine is accurately calibrated. So the first thing you need to decide when you are doing your calibration, which we now call, the reason why we are calling it range calibration now, is because where your echoes are going to come at will be dependent on your range. So if I say I'm calibrating with this block and I want to use a range of 100 mm, the first thing I'm going to tell myself is, if I'm using this block that at this depth of 25 mm for a range of 100, it means this is 25. For 100 is going to be 4. For 100 is going to be 4 echoes. So I'm going to get 4 echoes if I'm using 25. So one is going to be at 25. The next one is going to be at 50, and it goes on and on until we get to 100. So we are going to get 4 echoes if we are using this, if it is 25 mm. If I use a range of 125, it means I'm going to get 5 echoes. One is going to be at 2, which is 25. The next one is going to be at 4, which is 50, and it goes on and on and on. When you do that and we are done calibrating, if your echoes are aligned at where they should be, it means you have calibrated properly. So your range, you are going to decide. So this is operator determined. So you are going to determine what range you are going to use. So you can decide to choose 50, 100, 125, and so on. It's solely dependent on you. What you cannot determine is the second factor, which is your zero or your delay. If your probe is having a wedge, it means you are going to adjust delay. If your probe is not having a wedge, you're only just going to adjust 0. In some other cases, you can just adjust 0 and see what happens. If you are not getting the right value before you start touching your delay. In some other cases where you have a physical wedge on your probe, you need to play around with the delay. So you play around with your 0 and your delay, either one of them or both of them, and you see your echoes will be jumping around back and forth. That tells you that you have properly calibrated. So what do you do to eventually calibrate? Set your range, get the number of echoes. If the echoes are not falling where they are supposed to fall, even without getting your readings, you will know that this unit is not calibrated. You start adjusting your zeros or your delay until you get to the right value. Immediately you get to the right value, it means you've gotten the result you want and the unit is calibrated. Now let's practicalize the calibration. This is not a training, this is just to give an overview. If you go for your training, you will be told on how to input those information I told you about for your setup. But our emphasis here is just to understand the whole concept of this zero and range and delay, and how to do your calibration. If you are doing for 0 degree, you can see this is a 0 degree probe. You are going to use a known depth or a known thickness. In this case, this is our V1 block. The thickness is 21 mm. 25 mm. The thickness is 25 mm, so we can use this 25 mm as our known thickness. If you look at the concept the way we explained it earlier on, if you count the number of graticles, which is divisions, like we said, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for your calibration, you will determine the range you want to use. So if I go to my range and I decide to use a range of 100 for this 25 mm thickness block, it will be 100 divided by 25. So I'm supposed to get 4 echoes. If I put this, I'm seeing 4 echoes already as it is. But the question now becomes, are they where they are supposed to be? If the equipment is properly calibrated and we are looking at 10 graticles, 100 divided by 25, I'm going to get 5 and 4 rather. In this 4, it means that 1 is going to be in 25. And if we are looking at 10 graticles divided by 100, it means 1 will be 10, the second one will be 20, the first one 10, the second one 20, all the way to 100. So which means 25 means the first echo is going to be between the second and third graticle, which is 25. We've already imputed the velocity and everything. So we're only left with the option of adjusting the 0. As you can see here, this is the value for the 0 and this is the value for the delay. So remember what we said, if we go to the 0 and we start increasing or reducing, see now I'm reducing it, the 0 started going backward. If I start to increase the 0, as you can see, it gets to a point where my echo is between the second and the third echo. I can come to my dB and reduce it down and take this echo down. But for us to be sure that we've accurately calibrated, we want to see that this echo is between the second and the third. That is even before you start looking at the readings, because as you can see right here, there are no readings. So we don't even know if we're accurately getting the right reading. But if we go and play around with it, even before touching the reading, you should be able to tell yourself that the first one should be at 25, the second one should be at 50, and the last one should be at 100. So if this is 10, 20, 25 should be here. This is 30, 40, 50 should be here. So you can see that this one is not on 50 yet. So if you go back to your 0, your 0, you can adjust a little. As you can see the values the way they are coming out. You can then go to your measurement setup. This is for this unit. This is peculiar to this unit. If you go to your measurement setup, you can come to the settings and all that, and do what your readings should be like. So you can come here and say it is automatic, and it will give you what you need. You come back here, you see this is 25.29. Even before I gated it, I already know that I'm already within the territory to show that my equipment is calibrated. I can go back to the basic setup for this unit and adjust my zeros until I get my 25.0. So as you can see, I have calibrated. So basically what I have done is, with my range and my delay and understanding how my graticles work, I've been able to calibrate this machine. So with this thickness that we have, we know that this thickness is 25 mm, and then we are taking a range of 100. And if we are taking a range of 100 and we divide 100 by 10 division, it means that 1 should be 10, 10, 10. So if we are going to take a range of 100, it means we are going to get 4 echoes. One should be at 25, the other one should be at 50, the other one 75 and 100, just like that. So I'm supposed to get one between 2 and 3, and of course this is the last one, 100, I should be getting an echo. This is almost where it should be. But if it is not, then what do you need to do? You need to go to your 0 and adjust your 0. Now we are getting very weak echo. We can increase it, and you see. So with our 0, if you come to your 0 and you adjust it, you can get to your 25 mm. So as you can see, we are getting, even in some cases you may not get exactly 25 mm, but If you get your 25 mm, so this can also apply. If I go to gate and I decide to gate, if I decide to gate this second echo, you will see that I'm going to be getting here, I'm going to be getting almost 50. Yeah, I'm going to be getting almost 75, and just like that. If you are wondering why we are not getting accurately the right value, it could be the electronics and also the adjustment that is possible, because if I'm at 75, if I adjust my 0, okay, sorry, this is 50. If I'm not getting exactly 50, I take the value that is closest to the 50. But just to confirm that your calibration is correct, if you come here, this distance from here to this point is 100. If you see it, it's just, even without getting it, I'm getting it somewhere at 100. If I go to this my echo and I get it, I should be getting a reading that is close to, you can see 99.57, which is almost approximately 100, 99.81. In case you are wondering why we're not getting exactly 100, we might not be able to get exactly that value, but the percentage error should not be more than 2%. So that is basically how you do your 0-degree calibration. For calibration of an angle probe, the concept is still the same. Range, delay. You are just adjusting your range and your zeros or your delay. What changes is that because you are using angle probe, you need a curved surface so that the echo that is coming is able to hit the curved surface. So you have your quadrant. So for your V2 block, you have your 25 mm quadrant and your 50 mm quadrant. While your V1 block, you have your 100 mm quadrant. How do you know? Just from this point, if you take a steel rule, measure from here to this point, it's going to give you 100 mm. If you look for the 0 point, which is somewhere around here, from here to here will be 25 mm, while from this same point to this point, we give you 100 mm. For just to get a concept, because for the 100 mm quadrant, which here is your point. If I put my probe here, it's going to bounce off and come back. This point is keep bouncing back and forth. But in the case of my V, you are going to discover that it doesn't bounce that way. So you have your 25 mm quadrant and you have your 50 mm quadrant. So normally what happens is that when the echo comes, it bounces off. Take note, your crystal is in this direction, which means it's only going to see indications that are bouncing off from this edge. So what that implies is if I get an indication, if it comes to this point, it bounces off, it comes back to this surface, a part will be read off by this, and the other part is going to bounce off this way. But this one that bounces off this way, by the time it's coming back, this crystal cannot read it because it's not facing that direction. So it will go back again, bounce off before it comes back the second time. Which means what you are going to get, a first bounce off at this point, at the 25 mm quadrant. So that gives you 25 mm. When it is coming back and bouncing off this wall, it's going to go 50 this direction. So you are now having 25 plus 50. But the one that comes out back from 50, you are not going to get it. So it goes back and bounces off at 25 before it comes here. So it does another 25. So you are going to get 25 in the first one. Then you get 25 plus 50 plus 25, which is 100. So for your V2 block, you are going to be getting two echoes, with one at 25. The next one will be 100. After the 100, you are only going to be getting from this edge. So the next one, what is the difference between 25 and 100? Is 75. So the next one is going to be coming at what? 175. So for me to get, this is where the whole conversation about range comes in. For me to see 100, I need to get a range of at least 100 and above. For me to get 175, my range has to be 200 or at least minimum of 175 and above. It goes on and on and on. So for your V2 block, whatever you are going to see will be clearly be dependent on. So if I put this as it is now, this unit, the values have been imputed, but the echoes are not coming out. But if I put this with a range of 125, for example, 125, it's 10 divisions, divide by 12, it means that one division will be 12.5. It means I'm going to get my first echo at 25, which is the second division, and the next one at 100, which is the 8th division. If you do that properly, by the time you adjust your range, those two echoes are supposed to come out. In the case of the V1, because you are getting reflection only for the 100, you are going to be getting echoes that are multiples of 100. So if I set my range at say 50 is not going to see any indication, because 50 is below the distance that I can get here. So for me to get repeated echoes of this 100 quadrant, I need to be setting my range to be multiples of 100. So I can do 100 or 200. If I do 200, it means my range is 200 and my distance is 100. So I can only possibly get 2 echoes, which means I will get one at my 5th graticle, and I will get the next one on my 10th graticle. Before you, like I always say, before you go into your calibration, you would have done all the setup and you have imputed your value. And if you look, this is a 60-degree probe, and this is my 100 mm. So for this block with this 100 mm radius, if we decide to adjust the range, for us to see an indication here, it means we have to do ranges that are multiples of 100. So if I do 200, a range of 200, it means I'm going to get 2 echoes. So now if I look at my range here is 125. Obviously 125 means I'm going to get one at 100 and I'm not going to get anything else. So let's say if I continue to work with 125, it means 125 means I have for 10 divisions, it means that one of these graticles will be 12.5, and this will be 12.5, 25, 37.5, 50 at the 4th one, which means I should be getting my 100 at the 8th graticle. So which means what I have here now, you know that this unit is not calibrated. If I go to my gate and I increase the level of my gate, I take it up, I go to the start point and I increase it. If I check on my readings, what I'm seeing on the measurement setup, what I'm seeing here is my depth. This is what I'm actually looking at, the sound part, which is 71, but I need 100. So what I will need to do is to go to my 0, just like we did in the 0 degree. I go to my 0 and take note, for machines, I'm using this Olibus Epoch 650. For machines where you find your zeros may be different. So I already know where to find my 0. So I go to this 0 and if I adjust the 0, you see the way my values change. So I keep using the gate to track it until I get to the echo. I go back to my 0. I continue to adjust my 0 until, if I look at it now, I'm getting 96, 97, 98, and there you go, you see 100.08, which is okay. If your calibration and your concept you understand very well, you will see that your echo will fall just on the 8th graticle. If you count 1, 2, 3, 4, 5, 6, 7, 8. Why it's falling on the 8th graticle is because your range is 125. If I come to my range and I change my range to 200, I'm going to have it in the middle. So I'm in 2, this is 200. You can see I'm still getting my reading at 100. It's just falling on the middle. If I change my range to 400, I'm going to get 4 echoes and clearly spread out. So basically, this is what you should get if your calibration is correct. So it's just an idea of playing with your range and adjusting your zero to ensure that your readings are falling where they are supposed to fall. Which means even without getting this echo, if I look at my range and I see where the echo is coming at, even without looking at this, I should be able to say, oh, this calibration is correct. So if you look at the angle probe, depending on the block you are using, if I'm using my V1 block and I'm using a range of say 500, I'm going to get 5 echoes. Because for 100 radius, for range of 500 is 100 divided by 5. So I'll be getting 5 echoes, which are going to be spread across the 10 graticles, which is 10 divided by 5, which is 2, 2, 2, 2. So it's just a matter of playing with your range, your zero, and your screen. If you're able to do this, even without getting to see your value, you already know that your calibration is correct. So basically, this is just the whole idea of the nutshell. This is just to give a conceptual idea. If you want to do it practically for those that are not youth technician, you will need to go for proper training, and then you will be taught how to do it. But this just gives us the concept for us to understand the whole concept of calibration using our range and then our zero. Thank you very much.